Hello reviewers, welcome to my channel Science to Technology. In today's show, Camera Tuesday, we're going to talk about wireless video transmitters. So let's dive deep into it. So what is exactly the problem that we need to solve this with wireless? Well, professional film set, meaning where you're getting paid, either it's TV or live shows or basically movies, generally they need multiple feed from the primary camera. And it is necessary for quality control, so it's not something that's like no, you have to have it. So focus puller can also be sometimes, like, again, a focus puller will not be on the goddamn crane focusing, pulling focus. So they also need a screen, and director also needs it, cinematographer also, DIT also needs it. That's why there is a whole concept known as video village. Basically, there is a, wherever shooting is happening, like, oh, things are happening here, cool, awesome, GG, there will be a tent bit far off, and inside that there will be people with a big ass monitor, and they will be observing everything. So this is a normal requirement nowadays. Now, okay, we have video village. What is the requirement of the video village? Video village is low latency, meaning focus puller cannot work if the focus that's coming there is slow. It has to work, like, it has to be like snappy, it has to be quick, it has to be almost 0 millisecond latency. So very low latency and uncompressed nowadays, that's a very desirable thing, because camera is recording in something different. Camera is recording in compressed LUTs, and so to say, log, when you hear logarithmic, so camera is recording differently. You get a uncompressed feed from the basically what you call camera. That feed goes into monitor. These monitors are so pro grade, they have the ability to load LUTs. Basically, you asked with your DIT, is like, okay, I'm using this camera, Venice camera, let's just say, what would be recording format? Okay, recording, what is the LUT? Basically, you don't want to show a log file to your cinematographer, he will be confused. So DIT will be like, okay, I'm gonna set the monitor and I'm gonna load the LUT in the display, not in the video file, just in the display. So it will look as if it was already graded. Again, it will not be final grading, but it will give you a good idea what you're looking at. So this is necessary in digital production. By the way, even film production has this nowadays. So that is there. And pro grade displays are already built for this, meaning, can you just buy a monitor that's like outdoor rated, robust, super duper hyper bright, and has all LUT features? Yes, that's done, sorted. How the heck you feed material to it? That's the hard part. So physical layer is the first tool we built to solve this, because all cinema cameras have this sort of port. You must have seen, like, silvery port. Yeah, they are they're even on film camera. So if you're like, hey, I'm using IMAX camera, they also have digital output. It's like, how? Well, here's a trick. If you have seen viewfinder, how the heck there is a viewfinder? Well, generally lens, film, and there is a shutter. Shutter is angled 45 degree generally, and it rotates. So when the window is open in that shutter, the disc, when the cut is open, let's say cut is 90 degree, film is here, exposure, block exposure, change the film, change the new one, it spins continuously. And that's why whenever you are looking into any sort of cinema camera, they will always say 90 degree shutter, 80 degree shutter, because when you are like doing those 80-90 degree, you have to physically change the shutter. Or sometimes you could have a mechanism that allows you to do that. Generally they swap out the shutter. Now that gives you the opening, but the other side generally is mirrored. Basically, it's silver mirror, and that mirror allows you to reflect light into something else. So basically, light that is going into the lens, it's either getting reflected into the eyepiece or getting exposed into the film. So you are seeing exactly what the lens is saying. Now in digital times, even if you're like Christopher Nolan saying, there is a tap inside it which is broadcasting it to digitally. That's why there is a digital mirror. So basically, focus puller guy will have a different system. So somebody could actually do this, like the framing. So this guy would be responsible for framing how the scene looks. Focus puller would be something else. So everything has that. Let that be very clear. If it's like, oh, it's like analog and all, it does not matter. Almost all things have that now. And how do we transmit signal? Well, we utilize serial digital interface, or SDI. These puppies are designed for this. Basically, they are shielded coaxial cable. I do not know whether you guys remember Dish TV. They used to have a coax cable. Work with radio, they have coax cable. Basically, it's a copper conductor with a dielectric, aka insulator, and then they have shielding, a ground around it. So these things are robustly built, meaning they are built strong enough that you can have a camera dolly crawl over it, and this will be like, I can take this. And because this has locking jacks, they do not go oops. So very strong. And because this was designed as a transmitter, They can go up to 100 meter. To give you a context how big deal that is, your normal HDMI will poop itself in 10 meters. Good luck even getting 10 meters. Like 5 and 3 meter is like okay, 10 meter good luck. 30 meters, yeah, please buy a converter that converts it into optical and then transmits it. So this is a very significant thing to have something that is just like without anything. 100 meters, like I got this. You can add repeaters, because again, if you are talking about a cricket stadium, 100 meter is too little. In those sort of scenario, you can have a repeater for that, and they have very low latency. It's a hard connection directly going into camera, and again, a focus puller do need a very low latency, so it does work. Locking connector is easy, splitters robust, trustworthy, but messy. And if you see in any James Cameron movies, it's like he has the camera, is like he's doing walking around, and there is a person behind it, is like always holding it, and then is carrying the cable harness. Yeah, it's messy. Again, there are people whose job it is to literally wrangle the cable. I'm not joking. Cable wrangling is a job requirement in a cinema industry. What do? I manage cables. Oh, like you manage servers? No. Monkeys running around, and I make sure that they do not trip over their own cable. Real life job. So that's a hassle. So we jumped into wireless system. Now again, is wireless necessary? Yes and no, because sometimes it's just not viable. Like, can you force it? Yes. So it's like, why? Like, for example, drones. Now, back in the before Russia-Ukraine war, if I said drone and fiber, people were like, nah. But now it's like, can't they just buy it? Like, you can fly the drones for like 2 kilometers and still have fiber connection. Of course you can do that, but it's messy. So yeah, no drones. Gimbals, because again, gimbals sometimes can move, and many times you have seen cameras that are like going 360 degree and all that. Yeah, that will put too much strain into the cable. And even if cable can handle it, camera body can handle it, the gimbal motor will be like, why the hell I have so much drag on me? So gimbals, vehicles, God help you. Like if you have like, F1 and people are actually driving on the track, then it becomes a hassle. And not all the time you will have like, hey, in the rear seat, the cinematographer is doing everything. Yeah. So at that point in time, it's like, yeah, we need wireless. Dolly and all that. So again, most of these things you can brute force physically, but having a wireless system makes your life easier and production faster. Money does not buy time, money only buys speed. So people are like, let's spend some money. Now be mindful, whatever type of radio system you are looking into, buy battery. So your cinema camera, which is really not that efficient in terms of battery, yeah, it becomes hungry puppy. Like it consumes battery like there is no tomorrow. Like a camera that's like, I can tank 3-hour shoot. It's like, yeah, 15 minutes, good, go, bye. These things are hungry. And to make sure that it meets the requirement, specifically the low latency of the industry, yeah, it does not use normal Wi-Fi protocol. Like it does not. It looks like it. The antennas could be literally same Wi-Fi manufacturer, and again they have the same frequency, 2.5 gigahertz. So, but again they are not Wi-Fi. The video pipeline is completely different. The idea is what we call radio to pixel, as in the radio is not transmitting a data packet that all data packet is being collected, then reassembled, then decoded, and then projected. Now it's literally decoding, and it's a video file directly. And what happens if signal degrade? Well, if signal degrade, quality degrades, but frame does not drop. Meaning, for example, if you have signal strength of this level, the design is built such a way that they're gonna have the core important data. Meaning, like this is a drone example. It's becoming very relevant nowadays. The drone is 3 kilometers away, you can make out everything. Drone is 4 kilometers away, you can still make out everything. However, the bit rate has dropped, the color quality is gone and all that, but again you can still make it, and still low latency. You fly very further, now you have noise, speckle, but you can still make out where is the horizon. You go to 7 kilometers, you can still make out the horizon and where is the beach line. And that's the core benefit. That's why whenever you see Ukrainian force, they are relying on real-time analog system, not digital system. They need something that goes to this, not like jitter or stuck or anything like that. It has to be real time, and it has to be extreme low latency. So the idea is basically the core structure. Like let's say this video file was decrypted. What will have that? Okay, have a gradient, a blue gradient, then have a yellow line, then have green blah blah blah, and then you have blue blah blah blah. So that will be in this basic layer. So you can always make sure what is happening. Then coarse detail would be there, as in like the core structure, like hair looks like hair, or at least have right color. So those would be coarse detail, but the texture, skin texture and all that goes into fine layer. Meaning at worst case scenario, you still have something, and these things does not do handshake. For example, your Wi-Fi has a actual two-way communication. Basically, you're like right now I'm receiving signal via this camera. The camera is packaging your data, sending it over Wi-Fi, and it is listening to, did you receive the packet? Yes, you received it. Okay, here's the next packet. That is fundamentally high latency protocol. So these things are basically scream and forget. It screams a frame, either you get it or you forget about it. There is no, oh, let me wait, let me check. No, it has to work in real time. So it is basically, if you know how old analog TV works, same thing, but with far more complexity. And again, this is the worst case scenario because these are tiny receivers, but when you're talking about camera systems, they are far more robust. And again, you're not supposed to fly your cinema camera 7 kilometers away from you. Now there are two options in the market. You have to understand two class of hardware. First is the pro grade. So generally you can figure out pro grade because they will have idiotically high price and people are still buying it, and it will be JSCC. That's the codec system. Basically they will say something like radio to pixel. That means it has the dedicated silicon and hardware built that allows you to achieve low latency. And why low latency? Well, again, physics does not allow you to go to zero latency, but low latency enough that if a person was directly connected versus wirelessly connected, they could not tell the difference. Double blind test, they could not tell the difference. So it has to be good enough for focus puller. That's their benchmark. Again, at short enough range, does not matter. Now, there are three companies in that. You have Teradex, these puppies, then you have V-Axis, and Arri also bought a company that had that. So Arri now calls it their own system, which is WVS. It's inbuilt into the system. So basically, if a focus puller is like standing somewhere and doing it on a monitor, how the heck you can do that? Well, because again, if I try to do that with this, it will not work because the latency. Again, hardware is the same. Is the silicon what you call a radio communication package. That's the different part. That JSCC, expensive as hell. Now these things are expensive but robust, reliable, and whole professional world relies on it. Nowadays people figured out we don't need that, we have very good autofocus. So they're like, hey, what if we made the same basically Wi-Fi that your mobile phone has, but like a dedicated chip for it. Basically, oh, you need encryption and decryption, have a stronger chip for that. Oh, you need a strong receiver, what if you have a bigger antenna? So that way basically they are streamlining it and using the same silicon that your mobile phone already has. And again, many times you will find that these things can broadcast to your iPads and iPhones and Android. Yeah, that means it fundamentally has the same thing. So the core is normal wireless. What does that mean? That simply means at best there will be 30 millisecond latency because again, it has so much stuff, so much crap it has to do. So yeah, it will be slow. Again, if you're not doing autofocus, it's fine. Holyland, DJI, Aaton, so they are there, but be mindful, these are two completely different category. And if you are getting paid, you will understand why people pay for these sort of things. Like again, be mindful, they are not only limited to cinema, they are also used in broadcast. For example, if you are running around with a camera for a music festival that is going on, you're gonna trust this, you're not gonna trust that. So because again, a degraded signal that is being broadcast real time, that is acceptable over a signal that jitter or because again, a degraded frame is a degraded frame. That's all you got. A jitter is like. So for that reason, there is a lot of demand for this, but be mindful, painfully expensive. So this was a presentation on this niche environment of wireless transmission. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.